So we're back with part 3. In the previous video we went over part 2, and in the video before that we went over part 1. So please make sure that you don't just jump to part 2, guys, because if you go back and you jump to watching part 2, you aren't going to understand what's going on. You need to click back to part 1. You need to watch part 1 in order to understand what's happening in part 2. And this video is part 3, so in order to understand what's happening in this video, you'd have to go back to part 2, and if you didn't watch part 2, you'd have to go back to part 1. Okay, so by the way, guys, before I begin, I know a lot of students are experiencing a high level of anxiety now, okay? Because your exam, for most students, the exams are like in a few weeks or in a month from now, and you cannot start taking actual action a few days or a few weeks or like 2 weeks before your exam. No, you need to start now, guys. So that's why all the students who have been joining my online sessions, they have a huge advantage over everyone, even if they've been doing really well, even if they haven't been doing well, if their marks were very low, because I'm exposing you guys to the most commonly asked exam questions that are going to be in your exam. So it's a lot better because when you enter your exam, everyone hates the feeling of seeing a question they've never seen before. That just elevates their anxiety to another level. But if you open your exam paper and you see a question that is very similar to what you've seen before, then it relieves anxiety and it builds that confidence, okay? And you obviously have a higher chance of getting that question right. Okay, so that's what we do, exposing you to the most commonly asked exam questions, having sessions each and every single day. And obviously we're not going to be able to go through all of those questions in like the 2 hour sessions that we 2 to 2.5 hour sessions that we have every single day. That's why I created like a little binge series just covering the questions that we aren't going to be able to cover in class. Okay, so this is really designed to help you guys elevate those marks, guys, because this is the last math or physics exam you're going to be writing. Okay, so anyways, if you want to join, if you'd like to get the advantage of joining, make sure you send an email so that I can share more details, how it works, the pricing, etc. But other than that, let's get started with the video. So they tell us that in the diagram we have TR is a diameter, so we already went through that segment over here. We are currently busy with question 10.1.3. We need to prove giving reasons that triangle SPK is similar to triangle PRK. So just like I said previously, guys, let me just quickly erase this. Just like I said previously, if you want to prove that two triangles are similar to each other, you need to look at the way their letters have been arranged in the triangle's name. So let's look at S. S and SPK. So let's just go back and actually highlight these triangles. SPK, okay, SPK and PRK. PRK. Okay, so PRK would be the smaller triangle. I don't want to make it too thick. Let me just, you know. PRK would be that orange triangle over there. Okay, so we have to prove that they're similar to each other. So let's look at S in SPK, S in SPK. So that would be this angle over here. Is S in SPK equal to P in PRK? So P in PRK would be P2. Yes, they are equal to each other. You can clearly see that I've annotated them with the same color. We've proved that in the previous question, guys. We already proved that S was equal to P2. So there, we already have a reason. We just need one more. Okay, then you're going to go back and see, is P in SPK, P in SPK, which is P3 plus P2, P3 plus P2, is it equal to R in PRK? PRK, which is R2 and R3. Okay, so that isn't really as clear, so we can continue on with the next angle. Is K in SPK, which is this angle over here, is K in SPK, which is this value over here, equal to K in PRK. So it looks like they have K in common, right? So we have SPK would be this triangle over here, right? So we have SPK, which is this triangle over here. And then we also have PRK, and they both share the same vertex, which is angle K. So they have angle K in common. Okay, I don't want to see some students make this mistake of thinking, like, let's take P for instance. They will think that maybe P3 is an angle that both SPK and PRK have in common. No, they do not have that angle. They do not share that angle, guys. Both of the triangles have to share that angle. It has to form a part of the size of that triangle. Okay, so don't make that mistake. So then what you want to go back and do is you want to write that S equals to P2 because we've already proven that, and you have to state which triangles we're working in. In triangle SPK and triangle PRK, S equals to P2 because we've already proved that. K2 equals to K2 because they're common sides. Therefore, triangle SPK is similar to triangle PRK because of angle, angle, angle. Okay. Then for the next question, Remember, if you prove that two triangles are similar to each other, you need to write down the ratios of those triangles, right? Because of equiangular. The rule for that is equiangular angles, right? Triangles. So you want to write down, because we've already proved that they were similar. So you're gonna write down SP. Okay, so you want to write these ratios down, but don't forget to state your reason because of similar triangles. We've already proved that there were similar triangles. Okay, so you just want to write that down for yourself before we continue on. Then for question 10.2, it is further given that SR equals to RK. So we know that SR equals to RK. So now we have to prove that ST is equal to the square root of 6 multiplied by RK. So now, what does that square root mean? When we see a square root, what do we think of? We usually think of like an exponent of 2. Maybe we think of like st squared, it previously being st squared equals to like rk. Right? We think of it like that. It's not always the case, but the minute you see squared, we always think of like identical sides being multiplied with one another. For instance, if we had like zy multiplied by zy, what answer would we get? We would get zy squared, right? So that's what we think of when we see that square root. I want you to always think of that. We could think of Pythagoras as well. So I want you to write down, anytime you see a square root in your ratio questions, think of Pythagoras and think of like identical sides being multiplied with one another. That's what I want you to think of. Okay, and the sixth, why do not try and rationalize this, don't rationalize it too much, guys, to the point where you're gonna get confused. But when we see that number, when we see that sixth number, we usually think of maybe a number being next to another side. Maybe we had like 4RK or something like that. Maybe we had 4RK plus 2OK, something like that. But where does that number come from, guys? The number usually comes from let's say for instance we had a diameter, for instance, right, and that diameter was labeled dk, right, and then the diameter is obviously made up of two radii, so then the center was s, so obviously it means ds will equal to sk because they're radii, guys. Radii is always equal to each other, meaning that we can change sk to being equal to ds, meaning that the entire dk line, the entire diameter will actually be ds plus ds, meaning it will be 2ds. Okay, so I just want to give you an idea of like where that number might have come from, but obviously that's not always the case, guys. I just want to kind of give you more clarity on that so you don't freak out when you see that on your in your exam paper. Okay, so now, remember, I asked you to draw like a little hierarchy of the most important theorems to think of when you are working through your Euclidean questions, especially ratio and prop. I always want you to think of similar triangles first, okay? Similar triangles are very important. Then I want you to think of the prop theorem as well. I want you to think of using Pythagoras as well. Think of using Pythagoras, trigonometry. You need to draw like a little hierarchy for a little triangle, a little hierarchy for yourself to just to have some strategy. Okay, similar triangles, prop theorem, Pythagoras, trig, think of those. Okay, the top at your list should be similar triangles. So we've already proved in this case, guys, by the way, we've already proved that two triangles were similar to each other, and I told you to immediately write down their ratios. Once you've done that, so you'd write down their ratios, and now we're going to see if we can actually use this as our starting point. Okay, so let's look at that. We have ST. Is ST a part of these ratios? No, it isn't. What about RK? And by the way, guys, not each and every single line that is a part of the equation doesn't have to be a part of the of your ratio. By the way, okay, just to make sure that, because it's not like ST and RK have to both be in these ratios. No, that's not the case. At least if one of them were, then we could use that as a starting point. So let's look at RK. So RK is a part of this fraction over here. We have RK over here, and we have to choose between two fractions, right? Now remember what I said previously, the square root usually tells us that identical lines were multiplied with one another, or Pythagoras was used somewhere somehow. So we want to look for a fraction that has two fractions that have identical lines or the identical sides, so that we can get that root, so we can get that exponent of 2. If we look at SP and PR, PK and RK, no, they don't have any identical sides. If you look at PK, RK, SK, PK, yes, they do have identical sides. We have PK, and then we have SK and RK. So if we were to cross multiply, what value would we get, guys? We would get a value of P k squared equals to sk multiplied by rk. Okay. So now the next question is, now what do we do, guys? We're literally so far from manipulating it so much so that it looks like that square root that we've been given at the beginning. We're literally at this point where we just have pk squared equals to sk multiplied by rk. And we need to make that look like st. We need to manipulate it to the point where it looks like st equals to 6 multiplied by rk. So how do we even get there? So I don't want you guys to think about it too much. Just follow the steps, right? Remember, the first thing on our hierarchy was similarity. Now I want you to compare the equation that we need to manipulate it into. Compare it to that equation that we needed to look like. Compare it to the one that you have. Okay. So we don't have st. By the way, we don't have st. We don't have we just, the only line that we have would be rk. So I want you to pay attention to the lines that are actually a part of this equation. Okay, so st, let's look at where st is on our diagram. St is this really long line. And also, guys, this is so important to remember. Hopefully you guys do remember that stk is a 90-degree triangle. If you've watched the previous video, we said that tr is a diameter, therefore it subtends a 90-degree angle because of angles in a semicircle. So p1 plus p2, I annotated that previously. P1 plus p2 was equal to 90 degrees, and then k1 plus k2 was equal to 90 degrees because of our diameter. Our diameter subtends a 90-degree angle. Okay, so we know that ST is a part of a 90-degree triangle. So what do we immediately think of? Pythagoras, right? So we know we're definitely going to use Pythagoras, where ST is going to be the hypotenuse because it is the longest side of the triangle. And not only that, it is opposite the 90-degree angle. So you're going to take ST to the power of 2 equals to SK to the power of 2 plus TK to the power of 2. Okay, so you just need to work with what you have. That's how we got to this part over here. So you're going to say st to the power of 2 equals to sk to the power of 2 plus tk to the power of 2, and your reason is going to be Pythagoras. Okay, so now what do we do, guys? We have two equations, and we somehow have to simplify both of them to the point where it looks like this equation over here. What do we do next? Okay, pay attention to just each and every single line that is a part of your equation, guys. Okay, let's pay attention. St is a part of it, so that's fine. What about TK, guys? Let's look at where TK is in our diagram. Let's look at TK. TK is equal to PK. Remember they stated that in the beginning, in the heading, in the extract above. They stated that PK is equal to TK, right? So we're going to replace the TK with the PK because they're equal to each other. And this is where everything starts falling into place. I'm going to go back and replace the TK with the PK, but remember to put it in brackets, because PK used to be TK used to be there. Now we're replacing it with PK because they're equal to each other. So now we have PK squared, guys. Now we have PK squared. Now this is literally everything's falling into place. PK squared, PK squared, okay? And then we have sk squared, and then we have st squared. So now what do we do? This is where everything's going to fall into place, guys. Now what we're going to do is we're going to replace the pk squared with sk multiplied by rk, guys, because we already said that pk squared equals to sk multiplied by rk. So we're going to replace this pk squared, like substitute it in. Basically, we're going to substitute sk times rk in the place of pk squared right over there. Okay, and this is where we just want to get rid of that pk, guys. We're trying to get rid of it. That's it. Okay, and don't forget to put sk multiplied by rk. Okay, because the whole point is we're just trying to really get rid of the unnecessary lines. Okay, like for instance, the only unnecessary line that we do not need is sk. Sk needs to disappear. Okay, and we're going to pay attention to sk in just a minute. So now we're left with st squared equals to sk squared plus plus sk multiplied by rk. So now what we need to get rid of sk. So now we're going to pay attention to where sk is on our diagram, or what information they told us about sk. So remember, they told us that this is so important to remember. Remember, they told us that sr equals to rk, and this has to do with sk, by the way, because sk is this line over here. Okay, and they told us that sr equals to rk. So let me just rewrite this for you. I'm just going to go back and rewrite this for you. Okay, so sk is what we're focusing on because we're trying to get rid of it. Okay, trying to get rid of it. So sk equals to sr, if you look on your diagram, sr plus rk. But remember, guys, they told us that SR equals to RK. SR equals to RK. So what we can do is, if we know that SR equals to RK, we can just change SR into RK since they're equal to each other. Okay, so, and this makes sense, guys, because remember, we're trying to get rid of, obviously you're not going to switch RK to SR because we want RK to stay, because RK is a part of what we're, of the equation we're trying to make it look like. Okay, so since SR equals to RK, I'm going to go ahead and replace the SR with an RK. So now we're left with RK plus RK, which is, since they're like terms, it's going to be 2RK. Okay, so we're going to go back and replace this part over here. Okay, we're going to go back and replace this part over here with 2RK. But please remember that it previously had an exponent of 2, so you just want to leave the 2 there. 2 RK. This was 2RK. 2RK. Okay. So, right, so we're just going to go back and replace the SKs. We're going to go back and replace the SKs with 2RK because we know SK equals to 2RK. We're going to enclose that in brackets. Okay. Okay, right. So now, guys, now we have to take the 2 to the power of 2, okay? So please remember to you take the coefficient to the power of 2 separately from RK. A lot of students think that 2RK to the power of 2 is just like 2RK to the power of 2. No, that's very wrong. That is wrong. Okay, we have to take it slowly. First, take 2 to the power of 2, which is 4. What is RK to the power of 2? It is RK to the power of 2. Okay, and then on your other side, 2RK multiplied by 2RK is going to give you an answer of 2RK squared. Okay, and then we still have like ST to the power of 2 right over here. So they are literally like terms, guys. For RK, they both have RK squared and RK squared. They're like terms. So if we add 4RK squared plus 2RK squared, we're going to get an answer of 6RK squared. So we're left with ST squared equals to SRK squared. And now we can finally get to our answer, guys. Now all we have to do is we have to take both sides to the second root. When we take this side to the second root, that exponent of 2 is going to disappear, giving us ST. And this is so important to remember. A lot of students don't always forget this. When you're squaring a variable, an expression with a number and different variables, you need to first think of square rooting the number first. So what's the square root of 6? It isn't a whole number, it gives us a decimal, so we're just going to leave it. We're going to leave it out like that. Okay, and then go back and ask what is the square root of RK. If you square root RK, you're going to get just, if you squared RK squared, you're just going to get an answer of RK. So you have to write them separately from each other. And just like that, we've proved that ST equals to the square root of 6 multiplied by RK. It's literally that easy, literally that simple, guys. I do suggest to watch this video over and over again until it is embedded in your memory. So even if this question seems like if it's a lot to take in at first, if you just go back and rewrite everything that I've showed you in the video, if you go back and maybe rewrite the answers of the memo, then you try and do it on your own, you're going to see how easy it is. Okay, it's going to flow. It's just going to be very easy for you. Okay, guys, so in the next video, we're going to be covering obviously some more Euclidean questions. So make sure you redo this question again. If you want the actual PDF version, then make sure you comment down below or send an email. But without further ado, we will see you in the next video.